Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afi bin Ahmad Nawawi. My matric number is CF220035. Today I will present about introduction. First, the highlighted region of Malaysia is prone to frequent flooding problems, particularly during cyber stationary flood event. This has necessitated the implementation of effective stormwater drainage design guideline mandated by Malaysia authorities. Next, the Manual Sarana Mesra Alam Malaysia MSMA serve a comprehensive guidebook that provide recommendation and benchmark for design efficient stormwater management and drainage system across the nation. Adhering to the rules established in the MSMA is crucial to prevent flooding and minimize environmental impact. The region experienced flash flood due to a combination of factors, including the absence of natural hill and flat topography, which cause water to accumulate during heavy rain. Additionally, the increased urbanization and development have led to impervious surface, such as road and building, which hinder rainwater absorption and result in rapid surface runoff. Last, by embracing sustainable water management practices and adhering to MSMA principles, the proposed stormwater management system can effectively mitigate flash flood, enhance flood resilience, and promote a more sustainable environment in the highlighted area. That's all from me. Thank you.
Okay, hi, my name is Faris Shafi bin Sharizal. So my matrix number is CF220205. So I'm going to explain the background of study of this project. So the first point is stormwater management in Malaysia is essentially about flood mitigation by managing the surface runoff during heavy downpour. It can also be applied in rural areas but is essential in urban areas where runoff cannot infiltrate because the surface are impermeable. The second point is the first urban drainage manual, training and design procedure. Number one, urban drainage design standard and procedure for Peninsula Malaysia was published by DID in 1975. This manual was prepared as a guideline for engineers in designing drainage system and had been referred to by various agencies at federal and state level for the drainage requirements needed for any development in urban areas. And the last point is this project of PFC 221103 require each group to come up with the best strategy of mitigation method on how to face the flash flood issue occurring very frequently at Taman University Parit Raja. So flood mitigation approaches fall into two categories, which is structural and non-structural. Structural forms of mitigation mitigate harm by reconstructing landscapes. They include flood walls, sea walls, floodgates, and evacuation roads. Non-structural measures reduce damage by removing people and property out of risk areas. So, as we know, Parit Raja always had a flash flood occur. So lately, at February, I guess, flash flood occur in Parit Raja. So it impacts many people. So this project is to find the best strategy of mitigation method to face the flash flood issue occurring at Parit Raja.
Okay, so I will be presenting on project methodology. First step is we select the design ARI for the drainage system, and then we divide the subcatchment into segments of homogeneous land use or surface slope, and then we estimate the overland flow time, and we estimate the flow times for all other flow components within the subcatchment such as curb gutters, pipe and channels. And then we calculate the rainfall intensity design ARI and the duration equal to the time of concentration from IDF data for area of interest. And then we estimate the C values for each we estimate the runoff coefficient for each segment if there are different land use. And then we calculate the average runoff coefficient. And then we calculate the peak flow rate for the subcatchment. And then we compare the C and the Q value. Thank you.
So next is for the data analysis. In this section, I will explain about how to estimating the peak flow of the area of our study. So first step, we identify the subcatchment for subcatchment 1, 2 and 3. Second step, we calculate the subcatchment area where the area for subcatchment 1 is 2.65 HA, subcatchment 2 is 3.84 HA and subcatchment 3 is 1.32 HA. For the step 3, select runoff coefficient C, where we determine that the C value for subcatchment 1 is 0.995. For industrial, subcatchment 2 contains two types of land use which are 0.5 for open space crossover and 0.95 for roads and highway. Meanwhile, subcatchment 3 is 0.54 for open space bush cover. Step 4, we calculate the C average values, where to calculate C average we get 0.95. Step 5, we determine overland sheet flow path length, L note for the flow paths in every subcatchment to calculate the time of concentration of each subcatchment. Step 6, we determine the slope of overland surface in percent, S, which we get 8.6%. Step 7, we calculate the T note. Use the Horton's and roughness value, which is n equal to 0.0275, where we get the answer is 6.87 mean. So for step 8, we determine the channel length for the channels in every subcatchment. Step 9, we calculate the area of channel, which is trapezoidal shape with the ratio 1/3. From the site visit, the depth of channel is assumed to be at 0.5 meter and width 1.3 meter. Then step 10, we calculate the wetted perimeter of the channel P, where we get the answer is 4.46 meter. So for step 11, we calculate the hydraulic radius, which is R equal to A/P, where A equal to 2.9 meter square, and we get the answer of R is 0.65 meter. For step 12, we determine the friction slope of the channel as by divide the different elevation by the length of the channel, and we get the answer is 0.03 meter per m. So to calculate the travel time in channel TD, we use 0.0275 in this step 13, where we get the answer is 0.37 min. For step 14, we calculate the time of concentration by using the equation Tc equal to T naught plus Td, and we determine the answer is 7.24 min. For step 15, we calculate the peak discharge Q, where we find the I from the graph. And these are the table of where the characteristic of the drainage catchment, and the table 4.2 is the calculation of time concentration Tc. So to find the peak discharge Q, we need to determine the I. So this is where we find the I from the graph of typical IDF curve, where we use Tc minimum for a drain AB 7.5, we get the answer of flow is 8.322, and for the drain BC, we use Tc min 8.7 and get the Q 10.1.
Assalamualaikum. My name is Muhammad Ridwan bin Ismail. My matrix number is CF220199. Today, I want to talk about the discussion for our project. For our project task, the area outlined in red is prone to inundation due to big magnitude of stagnant flood because of heavy rainfall. Rainfall that is heavy or persistent might result in an excessive build-up of water. Runoff and floods may occur if the land gets saturated or if the rate of rainfall exceeds the pace at which soil can absorb water. Other than that is flash floods. These happen rapidly, frequently in hilly or mountainous area, and are typically the result of intense rainfall over a brief period. Flash flooding occurs downstream when water flows quickly down slopes, causing streams and rivers to rise quickly. Last is human factors. Flooding can sometimes be caused by human activity, so to overcome this problem, we design the size of the drain using the rational formula by following the step from Masma to addition, so that it can accommodate heavy rainwater in the event of climate change, so as to prevent large floods from occurring again. Next is conclusion. As a result of this project, we may draw the conclusion that strong rainstorms, lightning, and human activity were the main causes of the large flood in the area of Taman University Parit Raja. Due to uncertain climate change, major floods also happen when there is a lot of rain in a short period of time. Because rainwater moves slowly, poor drainage management is another element that contributes to flooding. In the event of heavy rain, water will overflow from the gutter and induce flooding. The human aspect comes next. For instance, the tendency of people to scatter trash around will result in delayed or worse, blocked water drainage in the drain. Therefore, a mitigation strategy has been put up to lessen the issue of flooding. This strategy entails enlarging the roadside drain to increase the flow of rainwater, and percentage of major floods occur will decrease in Taman University Parit Raja. Thank you.